सर
6 PM का
हाँ है
Good evening, all of you. In today's session, we'll be discussing about certain important theory related to heat of a reaction. First of all, you know that to measure the heat of a reaction, you have to use enthalpy. Now, delta H, that is change in enthalpy, it is an extensive property. So, suppose you have a reaction and it so happens that whatever coefficients are there in the reaction, you know that we have to put the stoichiometric coefficients to balance the reaction. So if those coefficients are halved, then the enthalpy of change of the reaction will also be halved, right? So if the coefficients of the reaction are halved, then delta H will also be halved. That is because it is a extensive property. Suppose if you have a reaction where delta H in standard state is negative, so it will be energetically favorable, and if delta H is greater than 0, then energetically not favorable. And generally the heat of a reaction is heat of formation of the products minus heat of formation of the reactants. So this is the heat of reaction formula, and And if you are talking about an element or if you are talking about a substance in the pure form, okay, either if you are talking about an element or if you are talking about a substance in the pure form, then the change in enthalpy, the enthalpy of formation in standard state, it will be zero. Now, a little while ago, I was telling you that if the coefficients are halved, then delta H is also halved. So, keeping this in mind, suppose you have a reaction like this, A to B, 1 to 0 and 1 minus alpha to alpha. So, the equilibrium constant will be K equal to alpha by 1 minus alpha. Now, generally when we write heat of a reaction, okay, generally when we write heat of a reaction, it is for 1 mole. So here it is alpha. So for alpha it will simply be whatever is for 1 mole, that multiplied by alpha, right? So in a reaction like this, initially 0 and finally 1 minus alpha and alpha, so K will be alpha by 1 minus alpha. So generally when we say heat of the reaction, it is for 1 mole, so for alpha it will be this quantity into alpha. Now suppose if n moles of a gas changes state from P1 V1 T1 to P2 V2 T2, so delta H naught is delta U naught plus delta PV. So delta H naught is delta U naught plus P delta V plus V delta P. So delta U naught plus P into V2 minus V1. Actually P1 into V2 minus V1 plus V1 into P2 minus P1. So suppose let us say that n moles of a gas is changing state from P1 V1 T1 to P2 V2 T2. So delta H naught is delta U naught plus delta PV. So that is delta U naught plus P delta V plus V delta P. So delta U naught plus P1 into V2 minus V1 plus V1 into P2 minus P1. So we can use this formula in case you are wanting to use pressure and volume. Suppose if you have two different reactions, okay, and the products are A and B, and the heat of the first reaction is delta HR1 and the second is delta HR2, then the if the mole fraction of A and B is x and 1 minus x, then x into delta HR1 plus 1 minus x into delta HR2 will be equal to delta HR. So the overall heat of the reaction will be mole fraction into heat of the first reaction plus 1 minus x into heat of the second reaction, right? So here the mole fraction of A and B is x and 1 minus x. So overall heat of the reaction will be x into the heat of the first reaction plus 1 minus x into heat of the second reaction. Now, suppose let us say that if the enthalpy change at a temperature T1 is given and you want to find the enthalpy change at a temperature T2, so the enthalpy change at temperature T2 will be enthalpy change at temperature T1 plus delta Cp into T2 minus T1. So this is a formula to find the enthalpy change at a different temperature if at a particular temperature is given. Like say for example, if you have a reaction like this N2 plus CH2 is 2NH3. So first of all, delta Cp for this reaction will be Cp of ammonia minus half Cp of nitrogen plus 3 by 2 Cp of hydrogen. Now ammonia is polyatomic, so Cp will be 4R. Nitrogen is diatomic, so 7R by 2. Hydrogen is diatomic, so 7R by 2. So after calculation it is coming to minus 3R. So delta Cp is minus 3R. Now suppose this reaction, you know the heat of formation at 300 Kelvin, suppose, then how will you find the heat of formation at 1000 Kelvin? You just apply this formula. Actually this formula is called Kirchhoff's equation. So heat of formation at 1000 Kelvin is heat of formation at 300 minus 3R into 1000 minus 300. So if you know the heat of formation at 300 Kelvin, then you can use Kirchhoff's equation to find the heat of formation at a higher temperature like 1000 Kelvin, right? So these are the details of heat of a reaction, the topic for our class today. And now based on all this theory, I'll give you the usual homework. Question number 1. There is a reaction. Ethanol is decomposing to give this product, and secondly it is decomposing to give this product. So if the molar ratio of C2H4 to CH3CHO is equal to 8:1, then what is the energy involved? So first option is 14.31 kilojoule, second is 57.23 kilojoule. Third option is 48.14 kilojoule, fourth option is 66.31. Question number 2. So this is a reaction. You have to find the difference between change in enthalpy and change in entropy at 298 Kelvin in kilocalorie. And these are the options: minus 1.788 plus 1.788, 0.596 minus 0.596. So these are the options. Then we come to question number 3. So change in this enthalpy of formation of CO2, CO and H2O is minus 393.5, minus 110.5, minus 241.8 kilojoule per mole. So using this data, you have to find the heat of this reaction in kilojoule. So heat of formation of CO2, CO and H2O is minus 393.5, minus 110.5, minus 241.8 kilojoule per mole. So CO2 plus H2 is CO plus H2. You have to find the heat of this reaction in kilojoule. This is question number 3. And the last question is question number 4. So last question is question number 4. You have to say which of these is considered as heat of formation. Carbon in the form of diamond plus O2 is CO2. Second, half H2 plus half F2 is HF. Third, N2 plus 3H2 is 2NH3. Third, fourth, CO plus half O2 is CO2. Out of these, which one can be considered as heat of formation? So these are the 4 homework questions, and the homework has to be submitted by 9 p.m. tomorrow, that is 9 p.m. Friday. So that's it for this session. I'll end the meeting now. Thank you. Bye all of you.